All right. Today I will be going over codename Goose, how to install it, how to connect it with a Databricks served model, and how to begin playing with it. So what is codename Goose? Codename Goose is an on-machine AI agent, AI assistant that was built to really help, as it says, automate engineering tasks. Codename Goose was developed by Block and released earlier this year. A couple key features um, of Goose. It's open source, so lots of visibility. Like I said, it does run locally and is very extensible. It's built on top of the Model Context Protocol framework, which allows you to build your own tools and extensions or utilize tools and extensions um, that have already been built, connect those up to Goose, and give it the ability to talk and interact with a variety of different technologies or applications that you use. So Goose supports a handful of different LLM providers. In this demo, we're going to be connecting it up to a Databricks served Claude model. So let's take a look at what that looks like. So inside Databricks, under our model serving, we can see we have a handful of foundational models ready to use. In this demo, we're going to be using this Claude 3.7 model. So you can see this is just the Claude model being served up through a Databricks endpoint right here. So we're going to walk you through how to download Goose and how to get it connected with this endpoint and begin using it. So first step, we actually want to install Goose. And now Goose can be used as both a CLI tool and a desktop application. For this demo, we're going to be going over the desktop app, but I would recommend downloading both and learning how to use both. So I will install it using brew. So just running this brew install command. And you can see here, I now have my Goose application in my applications folder. So if I open that up, you'll see right off the bat, it prompts you to pick a provider. These are the LLM providers that we discussed earlier. And we're going to go with Databricks. So to set it up, we're going to have to give it a Databricks host. So I'm just going to copy that over here. I'll be using the demo field engineering workspace. And in order to connect to Databricks, Goose will use SSO. So you will need to have that configured in order to access the serving endpoints. If you don't have SSO configured, you can use tokens. But yeah, so we'll launch this here. And this is what the chat interface looks like. Let's configure this a little bit more. So going into advanced settings to actually connect to that model, that Claude model we're talking about, we're going to add our model, the provider Databricks, and we'll take that model name, copy that from up here. This Databricks Claude 3.7 Sonnet, just add that model. And so now if we go back, we can see that it is attached to that Claude model. If we go back to this chat interface, we can just ask, what can it do? It'll SSO. It's on a different screen right now. Let me see if I can bring that down. There you go. It SSO'd in. And there you go. Just like that, we've connected it up. It's accessing that cloud model. It's being served by Databricks. And now let's configure it a little bit more and have it do some engineering tasks for us. So if we go into our advanced settings here, talk about the extension, so the extensibility of Goose. You have some built-in extensions that you can toggle on or off here. I'm going to turn on the computer control. You can also switch on memory, uh, JetBrains IDE, or add a custom extension. So if you download an MCP server or you create your own, you can add it here. So really flexible and extendable, like I said. And just to give you an example of that, um, Goose comes with some extensions you can download. So here's a fetch extension for web content fetching. We can just install that straight from Goose, the Goose website. And just like that, we have a new extension, fetch. And we could toggle that on or off. Now, what we want to do in this demo is the goal, at least. I have some tables, some sample tables in a catalog. And I want to ask Goose to take the sales transactions table and the sales franchise table, explore them a little bit, and then create a script that will combine the tables and look at number of transactions per day for each franchise. In order to get Goose interacting with Databricks, there is no official Databricks MCP yet. So we're not going to use this extensions here, but what we can utilize are what are known as Goose hints. And so Goose hints is just a text file that's used to provide additional context about your project to Goose. And they come in two different flavors. You have your global hints file and your local hints file. The global hints file, the one that we'll be creating, will apply to all your sessions within Goose, and that's stored in our config directory, which I'll show you a little bit more about. But you can also have a little bit more specific local hints files that you store in root directories of a project you're working on. So if you have project-specific hints that you want to help guide Goose, you can store those in the root directory of your project, and that way you're not inundating your global Goose hints file with project-specific hints. So this is the route we're going to go down to kind of help Goose interact with Databricks. So in order to set up a Goose hints file, we're going to need to create a Goose hints file, again, in this config Goose repo. So I will just create that file real quick using a touch command right there. If we come in and we look at our config folder, we can see we have this Goose folder created. We can see I just created this empty Goose hints file. Within this config folder, there's also a config YAML, which will store some of your information. So here, that Databricks host that we just set up, that's the only thing in there right now. Let's go into our Goose hints file and actually populate it. So I have some hints already pre-written for Goose, and these are specific to really working with Databricks. So it's a handful of hints that really guide Goose on how to authenticate into Databricks, how to use the Databricks CLI tool, how to use the Databricks Connect tool, so it can do some local development for me. And really creating these hints is it's just a learning process, learning how Goose works, adding hints when you start to see certain patterns um, that Goose decides to make. So we've created that Goose hints file, we've saved it, and now we'll go back. I'll create a new session just to make sure. And then I'm going to prompt it with um, oh, before I move any further, the last thing I want to mention is Goose also comes with a couple built-in guardrails here. So it can act completely autonomous, meaning that it'll just run all of its actions on your computer without checking in. I prefer to use smart approval. So you'll see it'll check in with me before it makes certain actions. So that's an extra guardrail there to make sure that Goose doesn't just run wild. Um, but here's the prompt I gave it. I have a workspace. There are two tables. Can you write a script that will use these tables, create a new table which shows the total amount of spend per day at each franchise? I'm telling it to explore the tables so you know what columns to use. Telling it where to save that file, and that I want to be able to run it locally using Databricks Connect. So we'll take a look at what it does. Hopefully, it can get this right. Never know with demos. But right off the bat, it's just going to authenticate into Databricks. And again, it's going to be using the Databricks CLI tool and the Databricks Connect Python library. So in order to do work like this, you're going to need to have one or both of those set up, just like you would if you were doing any sort of local development. But here you can see it's running some shell commands to explore the tables I talked about. You can explore the output of those commands. So it's looking at the sales franchise, the sales transactions, and then it's going to create this script. And so you see the script executed successfully and created the table. Now it's going to verify that verified that the table was created by running a CLI command, a Databricks CLI command. Uh, it's attempting to run a SQL query here using the CLI tool, which doesn't exist. So it's going to see that error and try a different approach. I don't need it to actually explore this table for me, so I'm going to stop it for now. Uh, but let's see if we look at this file, it should have created a table, franchise daily sales, in our Databricks environment. So let's take a look here. Sure enough, there's franchise daily sales here. If we look at the sample data, we could see franchise date and the total amount. So looks like it's working. And the last thing I'll ask it to do is just, can you upload this file to my Databricks workspace? Um, and now it should use the command line tool to take that file that it created locally and push it up into my Databricks workspace. I have a Goose hint here that tells it um, the home workspace is my email, and you can get that using Databricks current user me. So that's why it's doing that. I'll allow it to import the script. You can see there it had the wrong syntax. It corrected itself. Again, those are things that you can begin to iron out with Databricks hints, or if there was an MCP, it probably would have one-shot that. But one thing I find incredibly interesting is how it can take the error output and figure out the correct syntax to actually use. So it uploaded the file, and then it ran a list command here to see that it actually exists, and then gave a little summary of what it did. And so we can check its work, go into my workspace, and there you go. Franchise daily sales.py at 10:55. I promise you it's 10:55 right now. And there's the script. And now if we wanted to keep going, we could have it build a job or a pipeline that runs this script, deploy that job and pipeline, etc. But I think that gives you a good rundown of how you download Goose, how you connect it with a Databricks served endpoint, and then really the power of Goose. All right, so the last thing I wanted to touch on today was really just highlight some of the key features of Databricks model serving and AI Gateway. So in the demo we just went over, we were using the foundational Claude 3.7 model. But you can also create your own serving endpoint, and I did just that. So I could show off some of these features. I created a Goose demo endpoint. And if we look at what's going on under the hood, all that's happening here is I'm serving up a Databricks model, and I'm serving up that same Claude 3.7 model that we were using in the demo. I'm just wrapping it in another endpoint. But if I wanted to, I could come in here and I could add a second model. So let's say I wanted to add an OpenAI model. I could add that as well, and I could distribute the traffic between the two, both on the same endpoint. So the user's still hitting the same endpoint, Goose is still hitting the same endpoint, but the model under the hood might be different, and the user would know no different. And then looking into some of the key features of AI Gateway, some big things that AI Gateway provides are really fine-grained usage tracking. So we have tables that track the metrics of each request. You can set up an inference table, and these inference tables will actually show you all the requests and responses. Save them in a Delta table. And right now I'm saving that in my Ryeworth catalog. You can add some guardrails to make sure that the model isn't giving off information you don't want it to. You can also easily add rate limits to make sure that certain endpoints aren't being abused. Could help keep costs down. And lastly, if we did have multiple models at this endpoint, we could enable fallback. So if that first model was failing for whatever reason, it would fall back to the second model. And again, the underlying user wouldn't see any difference, any interruption. So let's take a closer look at those usage monitoring endpoints. So if we look at this table, it's going to be in our system serving schema. And like I said, you can see exactly who requested, who made the request, some token information, and what model the request was against. So if we wanted to take a look, for example, at what requests I've been making, um, We can do that here. And I really just want to highlight how important this is, being able to attribute certain requests to specific users. If you're um, querying, the Open AI API, and you all have the same um, API key, it can be very difficult for an organization to attribute who is making which request. And this gives you a very fine-grained look at what requests were being made, some information, and against which model. And then taking a look at this inference table that I set up for this endpoint, we'll be able to see the exact request message that was being sent to the model and the response that the model gave back. And of course, you'll be able to see um, who made that request. And so with these two tables, you can really get a fine-grained look at to what's going on. It really helps to enable real-time monitoring. You can build alerts off of these, dashboards off of them. Really a very powerful tool. And so with all that, um, hopefully this is enough to get started. You can start to play around, and I encourage you to start building some cool things.